Hey, what up everybody? So anyways, we're gonna get to some more shenanigans with this. So check this out. I did buy some lights for the top part of the truck for on the front end of it. Never installed anything like this before, so I'll take you guys along for the ride. I thought these were like the smaller lights, like those little tiny ones, you know, what they have on trucks. These suckers are like big. They're massive. Like takes up like my whole hand pretty much. This thing is huge. You know, that's what they all say, right? Anyways, I'm gonna try to put them on my car, whether they're extremely big or not, and they might end up being like some sort of like spotlight, but I got them in purple. So just because I wanted to be different, I didn't really want white or really want the amber colored ones. But now that I think about it, I kind of wanted the amber colored ones because I'm like, because I could run them at night, but I'll still run the purple either way you look at it. White would have been cool because the size of them, they would have been like little spotlights on the top of the truck. Yeah, I did get some more sound deadening, so I started sound deadening the center hump area and the channel for the drive shaft and everything. So I will continue to do that as well, and then I will get these, the lights mounted up here. Don't know about spacing, but we'll figure that out when we figure that out. And I'll probably just set you guys up on time lapse for that and get everything figured out as far as like spacing goes and all that stuff. I did get a train horn too. Crazy shit. Yeah, that's not mounted there. Don't think it is, because obviously the hood wouldn't close. But no, I got an electronic train horn. And yes, I did ground it to the battery and then tap it. Yeah, luckily I plugged my ears before I did that shit. That's loud. Anyways, we'll get right to it. We'll get some more shenanigans and stuff like that with this thing. Hopefully try to get this build done and going. I know a lot of people of you are like really interested and want to run this amp and stuff like that. So this amp, if this is a Chinese built amp or Chinese board amp, then this amp will be fine. But if it's the Korean board amp and the Korean build of this, which is a Sound Digital clone, there's a problem with this chip right here, if you guys can see that. And this chip right here controls everything, and it controls the power in, and it tells the gates basically what the rail voltage is at, and because it has two different regulators inside of it. It has a 12 volt up to 13.4, and it will give you 151 rail voltage. After 13.5 to all the way up to 16, it will give you a rail voltage of 195 volts. So if I take this one right here, which is this R53, and I unsolder it and swing it over to meet this adapter, it will permanently lock it into rail voltage 1. But if I want to get it into rail voltage 2, I take this adapter, swing it over to this one here, and that puts me in 1. Then I have to adapt this one here. And then once I adapt that one, then it will allow it to go into voltage 2. But then I have to take these two right here, and I have to switch them out. So the ohms difference has to be set up differently on these, because this is a 43. No, I think I have to look at it. I think that's a 400 and 473, and this one's a 124. This has to be a 200, and I think this one here has to be double stacked 150s, or I have to get something higher. I think, I don't remember exactly how that goes. Once I do that though, then I have to come up here to, I think it's R60, I think it's R67. And then it will end up being, I have to change that out so it doesn't ground correctly or something like that, or send because that opens gate to ground. But once I take that off, it won't do that. And then it'll keep it at permanent rail voltage number 2, which will be 192 to 195 volts. But if there's any type of surging through the MOSFETs, like I don't think there's any like surge on high rail turn on or on amp turn on. It doesn't surge. Like there's no, it's not just going to be like or like spike. But because this amp takes forever to power up. It's like so slow. It's like goes through its service checks and it's like power, slowly adds power to the rail as it goes up, and it does its checks. But there's a problem with the gate resistors, because if this is the Korean board, these ones aren't right on here, and it makes it to where, I'm going to set you guys on the amp itself here for a second. So what it does is it makes it to where you have your on wave and your off wave for your MOSFETs. And what it does is the wave is supposed to be like this, so that the channel, you have on and off, and there's supposed to be a gap between them. And with those ones, since those gate resistors are so high, or yes, if they're fast, so it's off on is so fast that it's like creating a V in there, which creates a massive spike on the actual like waveform. You can see the spike because of the fact that the gates are turning on and off so fast for the MOSFETs. Yeah, and this actually has a rail system that has a pulse to it, so it constantly pulses in voltage to keep the rail voltage up. If you drop it down below 12 volts and you get down into like the 9 volts, it increases the amps. So that's what it will actually make the board really hot, because it's trying to pulse up to keep that rail voltage up. But anything below, I think it's like 10 volts, it'll start increasing the amp on there, or the amps on there, and then it starts to make the amp less efficient, and it starts to create a lot of heat in the board, because it's trying to keep that rail voltage at like 151 volts. So from 12 volts to 13.4, it will keep 151 clean volts going into the amplifier, into the rail. Anything over 13.5 to 16 volts will increase it on stage 2 for regulation 2, and it will regulate you at 192 to 195. I think it goes to 195, and then it just stays there. Well, the component's top limit of voltage inside this amplifier is 200 volts. So you see an increased spike, and it needs to draw to keep that voltage on the rail correctly, because it dips slightly and it forces the rail speed to pick up for how it pulses. It could spike and hit 200, and you're right at the component's limits. And so it's not really a safe amp, but what can you do, besides a lot of modifications? If you guys want to actually see the modifications that are needed to be done to keep this amp safe, stable, and happy, and to actually have longevity, since it's a clone amp that's just mass produced, and they don't really test them before they leave to make sure that everything, that the sine waves are actually proper, and that that the gates are working properly, and they're not too fast or not too slow, that it doesn't go through rigorous testing like you would with a more high-end premium amplifier. So there's a lot of stuff that needs to be done to get this to be correct, and you can check out Bear Vids. He actually did 2 live streams on this board. So this one might be a Chinese manufactured board. The one he did was a Korean manufactured board. It was completely unbranded, and it's obviously a Sound Digital clone, and he repeats that multiple times that it's a Sound Digital clone. But the chip that controls the power input like that, and on the side, basically, that I was pointing out, on that one, it was programmed bad. It had bad programming to make the gates faster, and so he had to slow down the MOSFETs by changing the gate resistors. So there's a lot of stuff that he went and he did to be able to get that correct. He literally went through and changed every one of those MOSFET gate resistors. It was quite the enduring process. I mean, you're sitting there soldering on all of these, and I'm going to pull you off there. You have to go through, and you have to do that, and then you have to do that, those two, then you have to do those two. Then you come over to the other side, and the other side is, so you have your off and your on. So this is your off, this is your on. And then the problem that I have to find out, I have to hook this up, and I have to put power to this board and see if there's a draw. There's an automatic parasitic draw unless you remove that and swing it over to lock it into power 1, which will bypass the chip output on here that sends it to here, which is automatically sending power from here. It sends it to here and sends it to the gate. Whether the remote wire is active or not, it sends power to the gate, which sends in 1.97 volts of parasitic draw constantly. If that voltage is increased slightly, like you have a battery that's 12 volts or 13 volts, it'll make the fans spin. They'll just kick on. So fans are constantly on, and it's constantly drawing. Anyways, somebody's here, so I'm gonna let you guys go, and I'll put you up on time lapse. All right, guys, so we did some testing, me and my friends. My friend has his car here, or had his car here. So we took this bad boy out, we hooked it up. And so this is the Korean board, not the Chinese board. I'm assuming it does have the dual rail system, but as soon as you plug power in on the ends down here without hooking the remote wire up or turning the amp on, or like you should with the remote wire, the fans automatically kick on. So his battery, or yeah, his lithium cell pack was resting at 13.4, and these just spun up right away, instantly. So there's going to be a parasitic draw in here, and these are going to turn on automatically. Now, what I'm going to do, because I know that there's still going to be power to the caps, power to the system. I don't want to fuck around in here because I know that the rail is probably still hot, and the caps are probably still charged as well. But what I'm going to do is, more than likely, I'm going to probably figure out, I'm going to watch Bear Vid's video again. I don't care about the MOSFETs turning on and off too quickly. I'll run that with that dirty spike that's in there and just call it good. But I'm gonna have to figure out the air soldering that he did over here, the hot air soldering, and get myself a hot air gun to be able to unsolder that one right there and flip it to there, which is gonna get rid of this, because it's gonna stop R53 from going to ground. And so I'm going to take that and flip that, and once I flip that over to R49 and connect R53 to R49 sideways, it'll still see power to here, but it won't see power to ground. That'll cancel these off. But again, that's more than likely going to lock it into rail voltage 1. So this amp's gonna be sandbagged, and it's only gonna probably put about 12K. It'll be efficient, it'll be good, but it's not gonna be amazing. It won't be the full 16K that it could be, unless I mess with those two right there and change the ohms resistance in those to be higher ohms resistance, so I can get a startup voltage, or set, it's actually the input voltage on this at, I think it has to be like 4.9 or something like that, and then it'll kick over into the high voltage rail system side of things. But there's also something up there that I have to do, if I remember correctly. So I'll probably watch that video like 50 times before I end up actually messing with this amp, since, you know, I've never really soldered anything before. I mean, I have soldered stuff, but I've never messed with micro soldering and air soldering and messing with the process, like the little diodes and stuff like that. So and the little resistors. So I would need to just watch the video a couple different times, figure it out, make sure I'm putting that in the right spot, and which ones that for the right ohm load or ohms resistance that I'm putting in there, and then I'll figure it out from there. I believe that that's probably going to be the only option if I want the high rail side of things, where no matter if I put in 9 volts, it's still going to be, it'll still charge the rail to 195 volts. Or if I put it at 12 volts or 11 volts, it's still going to charge the rail to 195 volts. If I don't do that and I only flip that one, it will stop this from happening, and it'll stop the parasitic draw, because it actually is programmed into that chip. And if you had a chance to, and you can unsolder that and change that chip and it didn't have the programming in it, or if you could unsolder it and solder it to the programmer board, and hook that into your computer to be able to get into the software to actually reprogram that chip, you could take out the low rail, and you could make it to where that the rail, since it has dual regulation on it, you'd take out basically the first regulation link in that. You'd also make it to where that it didn't see ground on certain things, and you have to basically kind of reprogram it. At that point in time, you would just change your on and off signal to the MOSFETs too, instead of having to go through and changing those gate resistors. Because if you don't do that, I mean, if you did it in here, you wouldn't have to do it here to change these. Because by changing the ohms on the resistors, then it ends up fixing the problem, because you can slow down the turn off and turn on faster type of thing, because they're just too close together for the on and off as the MOSFET pulses. But that gives you a dirty sine wave basically, and they're so high together, so close together, this wave and the on and off, that it damn near overlaps, and which is going to cause excess heat through the MOSFETs, and it can also cause the MOSFETs to pop, because if they get too close together, they overlap, it can cause it to pop, because it's not actually shutting the gate or opening the gate properly, and then it's just overcharging the MOSFET, and it'll just pop. So if you can reprogram that chip, then that'd be great. And if anybody knows stuff about computer boards and computer chips and stuff like that, and they have a board to be able to solder that to be able to reprogram it, let me know. I'll send you this amp and you can fix that for me. But yeah, and then I'll just pay you the, I don't know, $400 it would be to fix that. Because I mean, this wouldn't be a bad board and bad amp if you could just fix that chip and the programming in it. But right now, since it's a Korean built board instead of Chinese, that chip is programmed wrong. And that's what's causing the whole issue with these amps. So did I buy a dud amp? Yes. Did I buy a bad amp? No. The amp turns on, as far as we know, it never went into protect or anything like that. All we didn't even actually turn it on with the remote wire, because we just got to the point where we plugged the power in. As soon as it seen power, it loaded the caps, and those fans instantly started spinning, which means that leaving this in that mode is going to drain that lithium battery down to damn near nothing before those fans shut off. So we can't have that. The only other way to fix this fan issue is to hook these fans up to a switch and drill a switch like through the front plate and put a toggle on there. So just put a little toggle switch in line that would on and off those, so it doesn't allow it to have power going into them unless you hit that switch. But doing that probably doesn't stop the parasitic draw. It stops the fans from running, but it's still sending power into the rail, which is still going nowhere and just going back into ground slowly, because it's feeding it, and it's going to slowly bump that rail voltage up, and then has to go somewhere. So it'll either be sending it back to ground, or it'll just cycle load it through the board, and then your battery's just going to slowly keep dying and dying and dying until your car's dead. Or even if you have a standalone battery system for your stereo, you're going to come out and your lithium cells are going to be at fucking like 12.1, which is not good, because maybe even lower than that. They could be down to like 9 or 10, it's pretty bad. I think standard low charge that they ship lithium cells in is like 13.3, or 13.1. So it's having this amp drawing power like that is horrible. The only way to fix it is with a lot of modification. And if there's anybody out there that comes across this and watches this video that happens to know how to modify amplifiers and things like that, let me know if you're local, like in the United States. I will ship you this amp if you can fix it for me. Okay? That would be great if you can fix it for me. Otherwise, this amp is pretty much a dud. And I don't know if I'm going to be able to use it, and I might actually have to just go out and buy it, spend the money and buy a half bridge, like a really high, powerful half bridge, and just spend the money on it, because I don't know if I want to take the time to waste more money on another cheap full bridge. You know, I was thinking I was going to get a deal. This would be cool to be able to run. The only other way to run it is to run a dead man switch, and I don't really want to run a dead man switch. I mean, I could, because as soon as I unplug it, it's going to take a while for the rail voltage to dissipate and the caps to dissipate. And then next time I want to use it, I'm just going to have to plug it in, you know, just snap them together and plug them in. Well, there's an issue with that too, because if you guys look up LAF Audio, the guy has a, he has a Fiat, right? And he's running high voltage amplifiers inside of there that run, because it's an all electric Fiat, and he's running high voltage, using the high voltage batteries from the Fiat to feed to the amps. And with the amps that he's running, he had like dead man switches or quick disconnects inside of them. And in case he needed to work on the system or needed to do anything work with the system, he could disengage the high powered capacity battery from the system. The issue that happened was the amplifiers needed more current, so they hit a draw point, and they created basically a high current draw situation, and it actually basically sparked or arced in that connector, because it got so hot from it pulling power through it that it melted the connections down and damn near started his car on fire. He just lost power to his whole vehicle because it kind of sparked right there and surged, and then it blew the breaker, because he has a breaker system built into it. It blew the breaker system and killed his car. So he's driving down the road and boom, just killed the high voltage system to his car. And that's the only way that he figured out what happened, because he pulled over and he popped the back and saw that dead man switch connector was melted and all black. So if it went to kill the breaker, it probably could have took that whole car down. I'm not running high voltage though, but I'm just saying that's an example of why dead man switches or dead man plugs are fucking bad. Like they don't make a good connection point when they overlap each other. They'll set you guys up on the car, bam, might bounce. So the way that they interconnect, they loop over each other and lock, right? Well, if there's any type of gap in there where they can bounce around, it can create heat and it can create spark or arcing inside there, and it can be bad for the amplifier, because that amplifier could short out, pop all the FETs, all the caps, and just, you got a grill behind you, you got flames off that thing like that high, you know. Or it can surge into the battery, make the lithium battery explode. Now you're shooting flames out of the battery pack, out of the battery cells. So running stuff that can cause fault issues or that can be faulty inside of a vehicle when you're running extreme power build, stuff like that, is pretty dangerous. If you have a half bridge system, a half bridge amp, and you look at it saying this is a 16,000 watt half bridge amp, right? The rail voltage on that 16,000 watt amp is like 480 or 490 volts. Okay, so you're playing with some fucking high electricity there, you know? People think it's okay, let's just hook it up to a 12 volt car battery and it'll be fine. Yeah, it's fine. As your alternator kicks in, creating alternating current, and it's upping the power and the amps inside of the alternator is putting out more voltage and more amps because it's increasing itself. Now it's charging at 14.4, 15 volts. It's actually putting out like 400 amps, and it's pushing that into your amplifier, right? Now your amplifier amplifies that and pushes it across the high rail system, and should be almost double that on the output side. So yeah, it's nothing to fuck with. Like, you're not going to get electrocuted touching the amp, but if something shorts out or something goes out, there can be some big problems, you know, especially if there's like back surging or something, blowing batteries, blowing alternators. I blew it on an alternator one time, took out my whole battery, brand new battery, blew it in half. So yeah, voltage regulator went out, overcharged that son of a bitch to like, I think it was like 280 volts, and just blew the battery in half. So there's problems with doing this kind of stuff. Anyways, I figured I would kind of enlighten you guys on that whole situation. If you guys are in the market for a cheap sound digital clone, try to find the Chinese boards. Don't buy the Korean boards that are like this. If it comes from China, make sure that it comes from a Chinese manufacturer and that it's a Chinese board with Chinese parts, because the Chinese chip doesn't have that same problem with the parasitic draw where it allows current through the gate system to be able to go into the system at all. Right now what it's doing is it's allowing power to ground through the gate system, and it's causing those to turn on. So you live, you learn, you live, you spend money stupidly, and then you got to go spend more money. All right, guys, I'll see you later.